What is Jewish physics? Like,
Theoretical physics, like things that don't produce tangible, useful results. It's like math on paper only.
Like string theory, like how you can't really...
String theory, special and general relativity, quantum mechanics, things like that that don't have actual tangible applications in the world. It's just math.
Well, but you're saying that special and general relativity have no place in
the only argument that you'll find is that general relativity is always referred to as, you can't have GPS without it, but GPS satellites actually don't use it because they just use the difference in timestamp, so it's a bunk argument. But
But for approximations of like moving bodies and stuff, like Newtonian physics got us there for a period of time. Is it not more accurate mathematical representation of how to model the world? Even if it's not
there is no empirical evidence to suggest that there is. It's almost immeasurable. And then there's competing ideas that are mathematically equivalent too, but have different philosophical implications. So,
like, not involving Jews, and so therefore it's a
Einstein. I'm not going to hijack this chat to go off on this thing, but Einstein's entire deal was just that he suggested kind of a philosophical reimagining where there was no preferred place of rest, right? But his math, he didn't actually come up with any math. It was all a guy named Hendrik Lorentz. It was a Dutch physicist.
Like the guy who did Lorentz transformations and stuff?
Yeah. Literally, the math is Lorentz's math, but
he gave it to Einstein and said, like, Einstein, you take the fall for this. You become the most genius guy, and people will use your name as a noun too.
No, Lorentz had already published 10, 20 years earlier all of that stuff, but as a different physical reasoning behind it. And then Einstein just said, let's pretend that light is magical and there's no way to tell if you're at rest. There's no preferred, this is not moving. That's all he said. That's it. So. And appropriated
Lorentz's math for his Jewish physics.
Yeah, exactly. The Lorentz transformation is special relativity in
right.
everything, right? But it's Einstein's theory of special relativity. Right. This is what I mean by Jewish physics, right? All the Jewish physicists have I can't build anything by saying that there is no preferred reference frame or the speed of light is constant in all reference frames. That doesn't help me make anything. Right? That's just purely mind games.
Well, it's as a measurement, for instance, how we take the distance, with a light year. How we determine the distance between stars and planets and bodies and shit like that. That's all done, via the speed of light as a constant, and that's been measured.
But Einstein didn't discover the speed of light. He just said the speed of light doesn't change.
And that it's the speed limit, that nothing can go faster than light without mass. But the atomic bomb wouldn't work without energy mass equivalency.
Actually, it wouldn't. Energy mass equivalence was what was the guy's name? Millikan. E equals mc squared is not Einstein, it's Millikan. Millikan, he was the guy who did the electric charge, he quantized it. Real famous for the Millikan oil drop experiment. Yeah, mass energy equivalence they started toying with that idea in the 1840s, and I think for a while they were saying it was 1/2 mc squared, and then Millikan formalized it to mc squared. So
here. This equation looks way more fucking complicated than the oil drop experiment.
Well, the oil drop experiment, I'm just saying that's what he's famous for. That wasn't related. That was related to the quantities of charge, but that's just what he's famous for.
If I wrote a paper and didn't cite everyone in it to the degree that Einstein didn't cite his sources, I would be expelled for plagiarism. Done. No questions asked. Yeah. There was very little of substance that Einstein contributed to his theory. It was rhetoric, basically, is what he contributed, and it was bad rhetoric.
Mm-hmm. It's philosophical. It's not anything empirical. So that's my quip with Jewish physics. You find a Jew, you find an idea that's you can't test it, you can't measure it. It's just a philosophy. That's where you get things like the multiverse shit about, quantum mechanics and, infinite universes and all this shit. You can't test that.
Well, people talk about that all the time, where that's, if something's not provable, it's not science. You need to have a hypothesis and, data and make a conclusion.
You need to test it. There needs to be some empiricism involved,
Scientific
but all that
method.
got out the window 100 years ago, so whatever. Thanks, Jews.
But then, so like the experiments, like with the gravitational lensing and stuff that supposedly during the full eclipse where they measured the star's position and stuff. You're saying that Einstein, his theory.
Well, there's two issues with that, and one of them is that there are multiple competing ideas that people did not like Einstein's explanation for why that happened, that are basically mathematically equivalent. And the second is that they've never gotten good data for those. Like, if you actually look at the raw data, it's very cherry-picked. Like, there's no positive experiment.
At this point in time, like, what was the fucking breakthrough at the laser center, the LIGO?
Weev, do you want me to hijack your fucking thing and talk about this, or do you want to talk about something else?
Please.
Okay.
Let's do it. Like, school everyone on Jewish physics, please.
Okay.
Jewish physics is new.
Now, disclaimer here, I don't want anyone to think that Weev endorses my crackpot fucking physics ideas, right? Okay. So, what the whole LIGO thing with the gravitational waves is they used effectively a really fine-tuned version of a tool called a Michelson interferometer. Have you ever heard of that before?
I have not. I have no idea what that is.
Pretty esoteric if you're not in physics.
Reddit just locked my AMA. Like,
there you go.
Wow.
This is officially Jewish physics chat now.
Okay, it's Jewish physics chat. Let's go. Okay, so they used what's called a Michelson interferometer. This was originally envisioned sometime in the 19th century as there used to be the idea that light is a wave. It has to propagate through a physical medium, just like sound, right? You couldn't hear me if I was talking to you in a vacuum because there's nothing for the wave to be waving, right? So the commonly held thing, until Einstein was largely the one who popularized throwing away this idea, was that there was a medium pervading space, empty space, called the luminiferous ether. And it was light coming from the sun to the earth traveled through that.
Yeah.
And so Lorentz, actually, the Lorentz transformation is his mathematical model for how light propagates through the luminiferous ether. So basically the terminal velocity of an electromagnetic wave in otherwise empty space in the ether, right? That's what the Lorentz transformation was originally.
Right.
Einstein's contribution was he came around and said, pretend there's no ether and it's just moving through empty space. That's it. That's special relativity right there.
Right.
So in order to test this, what a guy named Michelson, actually Michelson and Morley, were two physicists who designed a thing, and what it is you take a beam of light, and
this is what the Michelson-Morley shit is, like what the guys who think the Earth is concave reference, not the flat Earth people.
That's a whole different argument, but
okay.
Yeah. So the Michelson interferometer, they used to think if the Earth is rotating around its axis and it's revolving around the sun, there's going to be a wind, kind of like if you're stick your hand out a car window, right?
Right.
They said, well, if light travels through this medium of the ether, we should be able to see kind of it getting blown from the motion of the Earth through the ether in space. So they set up, basically it's two arms with a bunch of mirrors and just mirrors, right? And so you start a light and you shine it straight ahead. And it diverges through a half-silvered mirror off two paths. One of them goes straight ahead, one of them goes off to the left. They reflect off mirrors, they come back, combine at the point in the middle, and then they go off to the right to a detector. And since light is a wave, it will have interference patterns, right? Like,
so
like you sine wave, right? Yeah. They'll combine to have areas that are intense and then will cancel each other out depending on the phase of the waves. If the Earth is moving and you line up one of those arms in the direction of the motion, right? So like you have one of the arms pointing due east, then it's going to cause the phase to come back at a different position in one arm than it would in the other, and you'll see a pattern of fringes on the screen. Okay. So an interference pattern. So instead of seeing just a blob of light, you'd see a bunch of lines. Right. And so then the thought is then as you rotate that interferometer, so that one arm's pointing east and then maybe one arm's pointing like northeast or whatever, the interference pattern should shift because you're experiencing a different wind from the ether. So that was that. They did that experiment. They did not experience a shift in the fringes, and so that was what inspired Lorentz to come up with his whole ether theory. and the Lorentz transformation is to explain how there's ether but there's no shift, right?
Right.
So LIGO is just a Michelson interferometer. It's the same exact thing, except what they do is they have lasers, they have really precise detectors, and along the two arms that go off at right angles, they have mirrors that are like, I don't know what percentage, I can't remember, but basically like once the light goes through, every time it comes back and hits the mirror, it'll only allow like 1% of the light to come through. So effectively, you've got this like super miles long path as the light bounces back and forth before it finally combines and goes to the detector, right?
Okay.
So then they just sat that thing up and they left it for years. And on September 14th last year, which, another coincidence, that was the Shemitah day, right? But we don't need to get into that.
What's the okay. Sorry,
7-year forgiveness of debts for the Jews. They always coincide with market crashes, right? But anyway,
okay.
That doesn't really mean anything. It's just a nice coincidence that it happened on that day of all days. So basically on September 14th of last year, they saw for about 10 microseconds, I believe it was the signal length, they saw an oscillation in the phase that was the recombined at the detector, right?
Right.
And it just was like a 10 microsecond signal, and then that's it. And so that is the entirety of the experiment that they have. Now, all this stuff about black holes and everything, what they're saying, oh, this must have been gravity that was like two black holes that were spinning around each other really, really quick as they got super close to each other, and that caused like a perturbance in the gravity that caused this shift and like kind of wiggled the light on one of the arms more than the other. Now, it's more correct to say, and this is what the paper says actually, if you read the actual journal article, is what they detected was a longitudinal electromagnetic wave, which is something extremely rare and doesn't necessarily mean anything about black holes or anything like that. But it is interesting because that would be one of the first times that a longitudinal electromagnetic wave has ever been directly observed. But that's not what they're talking about.
So it does have scientific implications, but you're saying
it does, but it's substantially different if you just look at, throw out all the untestable things about black holes and this stuff we've never seen, we can't look at and everything, and look at what did we measure. We measured a longitudinal electromagnetic wave, which is, do you know the difference between a longitudinal and a transverse wave?
I'm assuming...
Like a transverse wave is like a sine wave, right?
Right.
Okay, a longitudinal wave is like a compression wave. It would be like a wave in the ocean, like coming back and forth, or like sound waves are compression waves, right?
Right. Yeah.
So it's not like a sine wave. It's like the air being compressed and then having areas of less density in between it, right? Kind of wiggles back and forth along the direction of travel.
So you're saying it's like moving the paper that the graph is or that the wave is on, rather
or like
than...
a slinky, if you're if you're holding a slinky, right? That is what they detected. Now, that does not have really anything to do with black holes, but it is interesting because Maxwell, kind of the father of electromagnetism, he originally predicted that there should be longitudinal electromagnetic waves, and there were a lot of physicists talking about them in the 1800s, but they never really came up. And then Oliver Heaviside was the guy who formalized the current versions of Maxwell's equations, and they just kind of wrote out the whole longitudinal wave thing and forgot about it. So it has some interesting implications to go back and re-examine that maybe there was something there in electromagnetism that was missed. But as far as black
that's
holes,
considered like a fundamental force, though, like electroweave force and magnetism is all the same shit or whatever. Like that was what Maxwell did. He did all the electromagnetic. Yeah. He did Maxwell's demon to the hot knot.
Yeah, he did a bunch of thermo. As far as his electromagnetism stuff, he kind of when you talk about like unified fields, right? Like he kind of showed how there's a relationship between an electric field and a magnetic field, and like one influences the presence or behavior of another from the same motion of an electron, basically.
But okay, so now to tie this all up, like which Jew like issued the edict down for the fucking physics paper that like now it's become this like 90-person conspiracy where everybody says
it's not the whole Jew thing isn't really a conspiracy thing. It's not. There's a bunch of Jews wearing hoods that sit around a table worshiping Satan, doing all this, but
and decide the mathematical properties of the universe.
But there are a lot of Jews that have a lot of influence, and it's just their nature. It's reflexive almost for them to pull things in directions that they like. You know, they pull things towards their philosophies. They pull things towards their what's beneficial towards them. And there's a big just academic like circle jerk in physics for the last decades about all this meaningless Jew science where you can have a whole career in string theory or fucking relativity this or parallel universes that, and never fucking do one experiment in a lab and have an entire career about it, So like, there's this, and it's just, it's like the epicircles of astronomy from centuries ago, right? You know what that was? The whole system of the Earth is the center of the universe. So in order to explain the motion of the planets, they have these like spirograph.
Yeah, I've seen those. Yeah, that shit's insane. Yeah,
right. Heliocentric. So, at one time, that was like the standard belief system of science, and you were considered a lunatic if you questioned it, and not based on anything empirical, but just because this is the way things are. We know better. You're an idiot for questioning this. We already figured it out. But that's kind of what it is now.
With number theory, I mean, for a long time, that was just like extrapolated something on paper. Like, I mean, basically everything at the root of everything is mathematics. Like, there is a lot of things that you can't like that. The way that we understand, practical science, like as far as physics, as a mass in times acceleration, force equal mass times acceleration, that type of thing, it's measurable. We have experiments that do that, but a lot of math is theoretical. Like string theory, like it makes sense on paper, but yeah, I mean, does it prove what the universe is made of? No. Like,
that's just math.
It's just math.
I do take a different stance from you and say like the most useful math is useful, right? Like math should be pursued for its usefulness with whatever your application. If you're talking about math as it relates to physical sciences, what value does it have to talk about it if I don't have something empirical to back it up?
But in the case of relativity and stuff, though, like it does help predict like motion of galaxies, models.
Well, it doesn't. You ever heard of dark energy and dark matter?
Well, that's the whole like missing part of the fucking equation that we don't understand.
It's a band-aid because according to a lot of the theoretical physics ideas in the last century, when you observe distant stellar bodies, they don't move right. And so they say, oh, well, they must be moving differently because there's this invisible, untestable thing. Like it's a band-aid. There's a lot of astrophysicists who have a huge problem with that whole dark energy kind of thing.
Well, it's like what it would account for 80% of the mass in the universe. Like that?
So basically, what happens is they have all these equations that were worked out not by experiment, but just by doing math, right? And then they say, okay, well, I'm going to look at this thing, and I'm calculating that this thing is this far away, and it's moving this way, and I think it should be doing this. And then you watch it through your telescope or whatever tool, and it doesn't behave that way. Now, historically, science would say, okay, obviously I have a problem in the idea that I use to predict what I think this thing should have done, because I said it should do this, and it did something.
You're observing something differently than the mathematical model. Right.
Well, instead, what they just did is they invented this concept of dark matter and dark energy to say, well, if we just pretend there's this invisible thing here that there's no way to observe, then I can give it whatever properties I need to make it like squeeze in with the math that I already worked out. That's all it is.
But then fundamentally it just becomes another fucking variable in the equation. Like the cosmological constant, like when it was like taken out and then put back in, like with the universe accelerating or something. Like we have it. I mean, obviously, like our understanding of the universe, like changes and we update our theories. That's one thing about it. Like we rewrite science if science is wrong.
But now we don't update them based on empirical things. We update them based on like fashionable philosophies. That's the problem. And that's a very recent thing in the last 100 years or less that we've started doing.
I suppose.
And that's like I'm a big fan of Philip Lenard. He won a Nobel Prize for his work on cathode rays, and that was his whole argument. And an argument that a lot of people kept through the 1960s was that why are we abandoning empiricism in science and we're just going to, let's work something out on paper. If it seems cool, let's just try to shoehorn it to match whatever we can possibly do experiments for, or just forget about doing experiments altogether. You know, and what good does that do anybody? What? What'd you say?
I would say, yeah, it's like, what's the point of science if you're not doing experiments?
Exactly. There isn't a good point to it. Like, that's the problem I have with it, is like, why the hell are you studying physics to fucking shuffle numbers around on a piece of white paper? Like, that doesn't do anybody any good. You know, that's
neither does racism.
Racism does plenty good. Look at Germany in the 1930s. It was fucking great.
That's one of those like track shift. You know, I don't even know what fallacy argument that is. Like, it's not an attack. But I was just derailing it.
I'm not big on my fallacies, but no, I know. But yeah, that's my. I have a problem with like Jewish physics like that. You know,
I've never heard that before. The Jewish physics lobby.
You can get a very slanted view of it from the Wikipedia article on the Deutsche Physik movement, but of course it paints Philip Lenard as this fanatical racist that was a failed physicist and all this shit, and it's just not even remotely true. But there's been a lot of that, and it kind of got stamped out, you know, because we've had this big cultural shift in the last century, and then in the same time, like, Western nations and academia has become completely run by Jews. So, of course, you can't ever talk bad about the Jews anymore, right? I can't say, look at all these fucking Jews. Like,
you're doing it right now, and no one's showing.
Well, yeah, nobody's doing that. But if I was a professor at a university in the physics department, and I said, you know, I would like to investigate, you know, if I said I'd like to investigate the implications of these longitudinal electromagnetic waves that LIGO detected last week, and look at them in light of what it might have meant for Maxwell, I'm going to get fucking kicked out of the department for being crazy.
Because you're not feeding in the narrative, the Jewish narrative.
Yeah, and you know, it's not necessarily like we must defend the Jews that, you know, all the other people in the departments are saying, but this is like what's in vogue and it's what's acceptable. It's just like you can't go to a college today, like that fucking kid that got kicked out of whatever school in Missouri or whatever for getting on Yik Yak and saying, I don't think that black women are attractive, you know, like a couple months ago. Like, it's this little box that you have to think inside, and that's all that's acceptable.